In this lesson, I want to demonstrate to you how to solve some simple linear equations that have terms with brackets on one or both sides of the equal sign, like the one you see on your screen now. But before we do this, I want to do a little refresher course on expanding a monomial times a binomial. The 2 outside the brackets here is called the monomial because it's a single term, and the x minus 3 because it's inside a bracket is called the binomial. Since there's no sign between the 2 and the bracket, the operation here is multiply. So we take the 2, and this dot also means multiply. We have 2 times x, and then plus 2 times the second term, which is negative 3. You notice I put a bracket in front of the negative 3 because you can't have the dot and the minus sign right beside each other. So the 2 times x is 2x, and then the 2 times negative 3 is negative 6. Another way of doing this is you take the 2 times the x minus 3 as we had, and you write 2 times the first term, which is x, again with a dot, which means multiply, and then we put the minus first, and then take 2 times positive 3, so we end up with 2x, and then minus 2 times 3 is minus 6 again. The way we normally do this, however, is take the 2 bracket x minus 3, and in your head, you multiply the first term by the 2, which is outside the bracket, so you end up with 2x, and then you take the 2 times the 3 and put the minus sign in, you get 2x minus 6. The next one, number 2, is a little bit different in that it has a negative 3 outside, so you have to take negative 3 times both terms inside the bracket. And you have to be careful here because it's negative 3 times a and then negative 3 times negative 4. And this is where students usually make mistakes, so be careful. So it's minus 3a, and then negative 3 times negative 4 gives you positive 12. If we do this in our heads like we did the last one, we take the negative 3 times the first term in the bracket, so we end up with negative 3a, and then negative 3 times negative 4, and we get positive 12. And this is the way we will usually do these. What's important here is that in each case we got exactly the same answer. In the first case it's 2x minus 6, and in the second case minus 3a plus 12. To solve this original equation, the first thing you need to do is eliminate the brackets by expanding in the same way as I just showed you. So we end up with 2 times x, or 2x minus 2 times 3, which is 6. And then we just write down the negative 7 because the negative 7 is not inside the bracket, so we do not multiply it by the 2. Then we combine the negative 6 and the negative 7, so we end up on the left side with 2x minus 13 equals 5. Since we have all the variables on the left side, we want to get rid of the negative 13 from the left, so in order to do that, we add 13 to both sides of this equation. And we're left with 2x minus 13 plus 13, or 2x on the left, and 5 plus 13, or 18 on the right. Now we want to get positive 1x, so we divide both sides by the coefficient of x, which is 2. So we end up with 2x divided by 2 equals 18 over 2, or 1x equals 9, which is the answer. Now you can see that I have taken all of the red marks out. You can see how your solution should look in a logical sequential way. Let's do a second example where we have brackets on both sides of the equal sign. Once again, the first thing you need to do is get rid of these brackets. So you take the negative 3 and distribute it, because this is the distributive property. Negative 3 times a gives us negative 3a, and then negative 3 times negative 4, just like the sample we did, is positive 12. On the right side, we have 5 times a gives us 5a, and then minus 5 times 1, which is negative 5. And then we put in the plus 1. Remember, it is not multiplied by the 5 since it's outside the brackets. Right. Now we have negative 3a plus 12 equals 5a minus 5 plus 1. If we combine the negative 5 plus 1, we end up with negative 3a plus 12 equals 5a minus 4. You can see now that in 2 brief steps you have gone from an equation with 2 sets of brackets in it to one without any brackets and one that should look familiar to you. We have terms with variables on both sides of this equal sign. I like to keep my variables on the left, so I'm going to eliminate the plus 12 from the left. In order to do that, I have to subtract 12 from both sides of the equal sign. On the left, I end up with negative 3a plus 12 minus 12, which is negative 3a. And on the right, I have 5a minus 4 minus 12, which is 5a minus 16. Now I want to eliminate the 5a from the right side of the equal sign, so I want to subtract 5a from both sides. So I end up with negative 3a minus 5a equals 5a minus 16, or negative 8a equals negative 16. To get positive 1a, I divide both sides by the coefficient of a, which is negative 8. So I do that to the left side. But as soon as I divide the left side by negative 8, I have to divide the right side by negative 8. So we get negative 8a over negative 8 equals negative 16 over negative 8, or 1a equals 2. To do the checks for this equation, you substitute a equals 2 into the left side and right side of the original equation separately. When I do substitutions, I always put the value I'm substituting in brackets. In order to avoid confusion, in this case, I'm putting the original brackets as square brackets and the new brackets as round brackets. You're not required to do this. I just think that it saves some confusion. So now I've substituted the 2 for the a on the left side. And if I simplify what's inside the brackets, which you always do first, you have positive 2 minus 4. So you end up with negative 2. And outside the brackets, you have negative 3, and it's multiplied by negative 2, so you end up with 6. On the right side, we have 5 bracket a minus 1 plus 1. So I substitute the 2 in for the a, and again, I've changed the outside brackets to square brackets to avoid confusion. Now inside the bracket, I have 2 minus 1, which is plus 1. You multiply that plus 1 by 5, which is outside the brackets. You get 5, and you bring down the plus of 1, so you end up with 5 plus 1, or 6. So now if you look at these, you can see that the left side is indeed equal to the right side, which confirms that the value a equals 2 is correct. Now that I've taken out all of the red marks, you can see what the solutions to this equation should look like, with all the equal signs one above the other and everything presented in a logical and sequential way. Now it's time for you to try some of these equations on your own. On your screen you will see 2 equations very similar to the ones I've done. Pause the video now and try these on your own, and then restart the video and you can see the solutions that I have prepared for you. Just take your time to eliminate the brackets and you'll have lots of success. In this first equation, in order to eliminate the brackets, we multiply everything inside the brackets by negative 4. So you end up with negative 4 times x, or negative 4x, and negative 4 times plus 4, or negative 16. Then you bring down the positive 3 and write the 7 on the right side. So on the left side, you end up with negative 4x minus 16 plus 3, or negative 4x minus 13 equals 7. In order to eliminate the negative 13 from the left side of the equation, I'm going to add 13 to both sides of this equation. So I'm left with negative 4x equals 7 plus 13, or 20. In order to get 1x on the left-hand side, we divide both sides of this equation by the coefficient of x, which is negative 4. As soon as you do it on the left, you have to do it on the right. So you end up on the left with negative 4 divided by negative 4, or 1x, and on the right, 20 divided by negative 4, which is negative 5. On equation number 2, we multiply the m minus 3 by 5, so we get 5m minus 15. And bring down the 2, and on the right side you end up multiplying 2 times both terms in the brackets. You end up with 2 times m equals 2m, and 2 times 4, which is 8. If we collect terms on the left side, we have 5m minus 15 plus 2, which is 5m minus 13, and on the right 2m plus 8. In order to eliminate the negative 13 from the left side of this equation, I'm going to add 13 to both sides. So on the left side, you end up with 5m minus 13 plus 13, or 5m. And on the right, you have 2m plus 8 plus 13, or 2m plus 21. To eliminate the 2m from the right side of the equation, I am going to subtract 2m from both sides. This time I didn't leave a space between the 2m and the 21. I put the negative 2m at the extreme right of the equation. I just did this to show you that it doesn't matter where you put the numbers you're subtracting from both sides. So on the left we have 5m minus 2m, which is 3m, and on the right 2m plus 21 minus 2m, we end up with 21. To get 1m, you divide both sides by the coefficient of m, which is 3. So you end up with 3m over 3 equals 21 over 3, or m equals 7. I'm not going to do a formal check for these answers, but if you want to have some idea if the answer is correct, in the first equation, substitute negative 5 into the left side of the equation for x. Inside the brackets, you have negative 5 plus 4, which is negative 1. You multiply that by negative 4 outside the brackets. You end up with positive 4. Then you add the 3, which is 7, which is equal to the right side, so it's correct. In the second equation, you substitute m equals 7 on the left side inside the brackets. You end up with 7 minus 3, which is 4. Multiply that by 5, which is 20, and then you add 2 to get 22. On the right side, substitute 7 inside the brackets. So you end up with 7 plus 4, which is 11, multiplied by 2. And once again, you have 22, so the answer is correct. I've taken out all the red marks so you can see what the solution should look like when you're done. It's easy to follow and presented in a logical and sequential way. Math is not just about getting the answer to a problem. It's about learning how to analyze a problem, applying your knowledge to solve the problem, and then writing the solution in a way that's easily understood by others, which is a very important skill to learn. I hope this was helpful. Thanks for watching.